So quick practice 15. So Billy has 4 apple candies, 2 lemon candies in his bag. Tom has 3 apple candies, 2 lemon candies, and 1 mango candy in his bag. So and then Billy first draws a candy at random from Tom's bag and put it in his own bag. So graphically it's like this. So first draw a candy at random from Tom's bag and put it in his own bag. And then Tom draws a candy at random from Billy's bag and put it in his own bag. So like this. So the sequence is first I draw it from the Tom and then put it into the Billy, and then second put it in the take one from Billy and then put it back to the Tom. So find the probabilities that the mango candy is in the Billy's bag. So after the whole process, if the mango candy is in Billy's bag, so that means this mango. So you can imagine that actually the Billy needs to pick up from the Tom. But for the second process, you cannot take it back to the Tom in order to make sure that the mango candy is still in the Billy's bag. So the situation here is that first, in the first process, you need to take the mango. So that means 1 over 3 plus 2 plus 1 is equal to 6. And then after that, the Billy actually has 6 plus 1 in his own bag here. Okay, because you pick up 1, so we'll add 1 more candy. So and then in these 7 candies, in order to make sure that the mango candy is still in the Billy's bag, Tom can only get non-mango candy. Non-mango candy meaning that you can pick up the 4 apple or pick up the 2 lemon, like this. So then the probability will become 1 over 7. Second one is that the mango candy is in the Tom's bag. Now, so you can see that very clearly these two, A part and B part, is basically complementary event. The mango candy cannot be flied away, can only be in the Billy's bag or in the Tom's bag. So just 1 minus part A result, we will get the part B result. Finally, Tom draws a apple candy from the Billy's bag. Now we need to think of several situations here. So the key right here is the Tom draws a apple candy. So that is the second process. Tom try to draw a from the Billy's bag. Now actually here the probability that the Tom get the apple candy depending on whether the Billy getting the apple candy actually. You can see that this two is not the same. If the apple candy cannot be taken by Billy, then you can imagine that for Billy's bag, the number of apple candy will be less. Otherwise, it will be more than 1. So then the situation will become like this. So first, now we need to think of all the scenario. That's the key points for the probability as mentioned in the beginning. So for the for Billy's to take the Tom bag. Now let's say if the apple candy has been taken 3 over 6, so because we have 3 apple candies right there. Now, in this situation, the Billy's will have 5 apple candies in his bag, and totally there are a number of 7 in his bag. So then the probability that the Tom draws an apple candy will become 5 over 7. Okay, so this is the first scenario. The second scenario can also happen in order to make sure that the Tom draws the apple candy. Is that if if the Billies cannot take the apple candy. Okay, now these two are also 3/6, but the meaning is different. In here, the situation will become there are only 4 candies in the Billy's bag. So again, there are 7 candies in the Billy's bag after taking the first process. So these two scenarios add up, it will become 9/14. Now here, the 5/7 is talking about the Tom getting a apple candy given that the Billy get the apple candy. And then for this 4/7 is that the probability that of Tom get an apple candy given that the Billy cannot get the apple candy. Now this first 3/6 the meaning is the Billy getting an apple candy. Okay, so and then this 3/6 is actually the Billy cannot get the apple candy. That means okay, so that means for part C, in order to understand whether the Tom getting an apple candy, first we need to know whether the Billy can get the apple candy at the same time, or the Billy cannot get the apple candy, because it will affect whether the Tom can get the apple candy. The probability will be affected. And then using the formula we have discussed, so then it will become like this. So first we need to know that whether Billy has the apple candy, and then multiply, given that the Billy get the apple candy, the Tom getting the apple candy probability. Or in other ways, the Billy cannot get the apple candy, and then calculate the Tom getting apple candy given that the Billy cannot get the apple candy. Okay, so that's the meaning of what we are trying to do in the below. So this PAB 3/6 is here, and PAT given that AB is here 5/7, and this 3/6 is the PAB dash. 4/7 is this PAT given that AB does not happen. To make sure you understand part C, let me use a tree diagram to represent the whole process. So first, we take a look at the first process. So first process is that whether the Billy get the apple candy or not. And then after this process, we look at the process 2. Okay, this is the second process. So depending on whether the Billy gets the apple candy, then you get the certain kinds of whether Tom gets the apple candy. So it become like this. So in the part C, we concern whether Tom draws a apple candy. So become the first branch and the third branch. So here, for the first branch is talking about AB and AT to be happen at the same time. It's actually talking about here, AB and AT happen at the same time. Okay, and then for the third row is talking about AB does not happen and AT happen at the same time. So in the formula we have shown is this one representing that one. So this is the relationship between the tree diagram and something that we have written in part C. Now let me make it more clear for the tree diagram. So for the AB and AB pi, both of them are 3/6. And then for AT, if AB is happen, so that means that there are 5 apple candy in the Bailey's bag. So that means there are 2/7 probability for AT pi to be happen. So in other words, for AB pi happen, then the AT will become 4/7 because there is only 4 apple candies right there. So that means the AT pi will become 3/7. So you can see that for our equation is basically multiplying the 3/7 with the 5/7, and then for this 3/7 we multiply the 4/7 and then add them together because they both either this happen or this to be happen. So add them together.